Once electricity is generated, it's put onto the line. Transmission then takes it from the generating station through a substation switchyard into our residential areas, commercial areas, industrial areas, where there's another substation that takes the higher voltage and converts it to a lower voltage so that we can use it for everyday use. Transmission operates between 115 kV or 115,000 volts up to 500,000 volts. 345,000 volts is our highest transmission level that we have, but there are some areas in the country that do have 500 kV. Normally, transmission lines will be overhead. However, at times there could be high voltage conductors or high voltage cables at transmission voltages buried underground.
The crew you see behind me is installing a new underground residential system. Voltages up to 7,000 volts, down to 120, 240 that goes into your house. This is typically a new installation. There's thousands of miles of this stuff in the ground. It's not uncommon for underground systems in Iowa to be energized at 13,000 volts. Primary cable is buried at 42 inches. The secondary cable goes in at 24 inches at the time of construction. You can never trust those depths due to developers coming in afterwards and changing the grade. On our primary voltages, you could find one cable for a single-phase circuit or three cables for a three-phase circuit. On a three-phase circuit, you cannot trust that all three cables will be next to each other. There could be as much as a foot of separation between each cable. Your locate company should be able to help you determine how many cables are on that particular circuit. As you're digging around these buried facilities, I think complacency can be very dangerous. We all develop shortcuts. You need to develop good rules and follow them every time. The potential cost savings for any shortcut is greatly outweighed by the potential injury to their employees. One common misconception is that the line will trip if the underground facility is cut. That's not true. It could remain energized, or your machine could become energized.
If an excavator strikes a primary conductor, the system is designed to trip. However, the fault may actually be seen as load on the system. So what it does is it increases how much energy gets transported to that location.
If you're running a trencher and you trench into an underground facility, your machine will become energized. If you stop and your machine is still making contact with the underground facility, when that operator steps off of the machine, there's something called step potential. When a facility's cut, the electricity can dissipate out through the ground. He's stepping to a different potential, and that creates a hazard for the employee. The step potential phenomenon is a lot like throwing a rock in a pond. You have the point of impact, and it ripples out from there. So imagine that center wave is 7,000 volts. As you step away into another wave, you could drop off 2,000 volts. That difference of potential is what can hurt you. If you're operating a rubber-tired machine, you're not necessarily safe either. If you're operating a backhoe that has outriggers, that's a path to ground. If you make contact with that underground facility, the electricity can travel through the machine, energizing the machine and the operator, and travel through the outriggers to the ground. When our linemen go out to expose underground facilities, we always train them to de-energize the system if possible. The average excavator doesn't have that option, so they need to use extreme caution. It's hard to put in words how powerful electricity can be, but you absolutely do not want to come in contact with it.
Immediately upon contacting electricity, it's likely you will feel some of the worst pain you've ever felt in your life. Your muscles will contract. You may have an inability to breathe as your respiratory muscles stop functioning. You will suffer terrible pain as the pain sensors in your body are stimulated by the electrical current. If there is enough current, or the current is focused enough, you will have rapid tissue burning. And then, of course, depending on the type of shock and the way the shock occurs, you can have compressive injury from the pressure wave and blunt force injury from falls, contortions, and impacts. Do I need to contact a high voltage circuit directly to be injured by it? The answer is absolutely no. As you approach a high voltage circuit, Electricity can actually jump out to meet you in the form of an electric arc. You do not have to touch the circuit. The arc can come out and bring the electric current directly to you. Whenever electricity enters the body, it also has to exit the body. If you were to draw a line between the entry point and the exit point, that would be the current pathway. Anything along the current pathway is at high risk of being injured. The most common form of injury is thermal injury. Thermal injury is caused by the rapid heating of tissue, leading to burns and organ damage. You can have thermal injury anywhere along the current pathway between the entry and the exit point. There's also non-thermal injury, and non-thermal injury can appear almost anywhere in the body, and we know now that it can be disproportionate to the shock itself. So even a small shock can cause devastating and debilitating long-term effects that are of diffuse nature and can be distributed throughout the body, even off the current path. Then, of course, there's the long-term symptoms. Long-term symptoms can be terrible tissue scarring from the external burning, organ damage and failure from internal heating of the body. Generalized long-term pain throughout the body is not uncommon. Long-term fatigue is also not uncommon. People who suffer electric shocks can also suffer debilitating personality changes, increased anxiety, short-term memory loss, and many other equally terrible symptoms. No contact should ever be considered trivial. Internal injury cannot truly be measured except by time. Some shocks lead to full and absolute recovery, even if the burns were bad. Some shocks, however, even with minor burning, can manifest lifelong and debilitating symptoms.
I was working with 7,200 volts. I was working on a primary single-phase underground tap that fed an overhead primary tap. I got up into the bucket and was doing the underground riser that fed the overhead line. And in that process, I had my gloves and sleeves on. I was doing everything right at that time, and just finished up terminating the cable, and I had the concentric underground left to connect, and I was just wringing wet. It was about 10:30 in the morning, and like I said, it was in July when this took place. I yelled down to the guy on the ground to throw me up a connector so I could connect that, took my gloves and sleeves off, and when I turned back around having the concentric neutral in my left hand, I hit the energized cutout with my right shoulder, entered through my right shoulder, blew out my left wrist and my left hand. I fell over the neutral wire and pushed myself back up into that again, and then that time it just blew me down into the bottom of the bucket. And it was really, it was complacency on my part. I'd done it so many other times, you know, that I took for granted what my surroundings truly were. I can't express to you the amount of pain that I was feeling. It was a pain like no other. It was like I was on fire from the inside out, from my bones all the way out to my skin. There was absolutely nothing that they could do at that time, obviously, to control the pain. And when this took place, I can remember screaming and yelling, "God help me." So once they got me to the hospital, the ER doctor came in and explained that there's a chance that your organs could shut down, your kidneys, trying to process the burnt tissue within your own body and the breakdown of that. And there's a chance that you might not make it through this. I remember waking up 6 days later in the ICU, and they had done 3 surgeries. During that time, they went in and did debridement and opened me up for compartment syndrome, where it gets so swollen that it constricts your blood flow to your limb. And so what they have to do is they have to slice you open and let it expand and swell until it starts to gradually go back down, and then they can go back in and they can stitch you up and clean you up. Not only did I spend 32 days in the hospital, but I spent countless hours with a counselor going through the accident. It's just like anybody over in wartime that has gone through a serious injury or anything like that. It's called PTSD. I can remember driving down the roads and look over at the power line. This was probably 6 months after the accident had taken place, and having a panic attack, thinking that I was having a heart attack. It just brought back that memory, and it was so vivid and so real. I have been out there in the audience and I've watched people give presentations. I've seen presentations, and in the back of your mind you're thinking, oh, that'll never happen to me. You know, we're conscientious about what we do. We work safe and we work hard. But let me tell you, I felt that same way, and it can happen to you, and you don't want this to happen to yourself or anybody around you or anybody that you know, because it's the worst thing that you could ever imagine.